Bonjour, mesdames et messieurs. Je suis suédois. Je ne parle français. Je parle suédois. So, unfortunately, we have to take this session in English. I hope you all are forewarned. So, this session on domain-driven security and how to make your code secure by design.
And my name is Daniel Deogun. I'm the coder and the quality defender in our little team here.
So that makes me Johnsson, the secure domain philosopher.
And I guess we're both from a company called Omega Point, and that's a company that focuses on application security and the crossing between that and application development. So we specialize in both, actually.
Yeah, and actually, as a coincidence, we are actually currently writing a book on the crossroad between application development and security, secure by design. Available through the MEEP program of Manning. We have released the first 3 chapters, more in progress, and the final book will be out end of year, beginning of next year. If you want to jump on the MEEP program, we've got a discount code. Don't need to write that down. We'll tweet it out. Link and code.
All right. So, but Dan, security. From my understanding earlier is that you have usually a security team that takes care of everything. So is security really a concern?
For developers?
Yes.
Of course. We have the security team. They do the security work. We do not need to do anything about it. Well, it turns out that security is actually a concern for business. It's a business concern. Anyone here heard about the Standard Oil and Gas last week? Website with journalistic content. They went to Mozilla and said, could you please remove the warning sign that Firefox shows? Because it says that our website is insecure, and it's not, because we have our own security system, and it's never been breached.
Well.
And 2 hours later...
Well, something else happened, I think. Oh, there we go. What happened was that somebody extracted all their source code. They found out that the database was responding, I guess, to port 1433, and they did the good old Bobby drop table command. Yes. So
and it all was due to a very classical SQL injection flaw, which, as the source code was possible to pick out the source code through the vulnerability itself. We can see here how they actually concatenated strings together to form the source code. So they went out of business. The website is gone. The database table of all the users is gone. So,
well, maybe they have a backup, or at least a hacker has a backup, I guess.
Yeah.
But
someone was merciful enough to drop the table for them so that not everyone would have a copy.
So the thing is that security is a real concern for everyone, and that includes us as developers and businesses and such. So what we will cover today is really first a case study. We're going to go over an example where a -1 number of HAMLETs is actually causing a huge business integrity problem.
A lot of money lost. We'll proceed to then look at what could be done about it. If we do this with a conscious design, we would probably design it as domain primitives, and we will walk through what those are and how they would help.
And of course, that's on the low, tiny level. A bigger, broader scope is context and how they map between them. And then we'll also start to looking into legacy code, because we all know that we tend not to work in greenfield projects. We tend to be in the brownfield area.
How many here are working in a brownfield, a legacy code base? How many are working in greenfield projects? Well, I guess it's your first week in the greenfield projects. Otherwise, it's just turned into brownfield.
And then we're actually going to focus on something called domain DOS attacks. And that's an area that's still in progress, and it's a huge problem out there, and we don't really know what the solution is yet, but hopefully we will, with your help in the future, find out how to deal with it.
So the first 4 is where we have developed designs and principles we'd like to share our experience with you. And the fifth is a little bit of an outstanding question.
So, but when you think about security, you tend to have the information security in mind. And that's regarding confidentiality, integrity, and availability. But this also applies to how you design your code, right?
Yeah. There's a tendency to think about that when developers think about security, they think about login, authentication, cryptos. How many have got that kind of mindset that, oh, when someone says security, I think about cryptos? It's pretty easy. But if you look at what information security experts say, they talk about security as concerns. Integrity, confidentiality, secrets should stay secret.
And of course, integrity, that you should not be able to change things unless you're authorized, right?
And availability is often not thought of as a security concern from developers. But security experts really uphold availability as a security concern. If there's an accident, an emergency, you want to call emergency service, fire squad, ambulance, and they are not responding to phone calls. Is that a problem? Is it a security problem? Yes. This is a security problem. So availability, that you actually can get to the data when it's needed, is a security concern. So these are the three classical, and what we will try to connect back our designs to.
Right, so design, I think that's an important thing to understand, and especially the way we look at design. And this is an extract from our book, of course, and it says, basically, any activity involving active design decisions making should be considered part of the software design process and can thus be referred to as design. And that really means that every decision you make, should I use an if statement? Should I model it this way? Should I inject code that way? How should I do this thing? It's not just, the UML diagrams on a board.
Design is often perceived as the class diagram and interaction diagrams in UML. But we have a much broader definition of design, from the code you write to the architecture you do. It's all designs.
It's actually coding,
yeah.
Right? You're coders, you design things, you build things. That's what you do.
So this is the purpose of this presentation, is to look for deliberate design patterns that we can deliberately use to be able to reduce security risks. So we don't have to think about security all the time.
But wait a minute, this talk wasn't called Secure by Design, it was called Domain-Driven Security.
True, because what we want to focus on in this presentation is the part of Secure by Design where we focus on the influence from domain-driven design. We have found a lot of, when we were looking for these design patterns that help security, we found a lot of inspiration in domain-driven design. So the field of domain-driven security was found in 2009, and it's about taking ideas from domain-driven design and using them as tools to address security concerns. And this is the interesting part. Even though those tools, value objects, strategic mapping, etc., were not originally conceived to talk about security. They just happen to be effective.
So with all of this, together you will help, you become a programmer that can design secure software without actively thinking about security. And that's pretty nice, because honestly, nobody likes security.
I don't like to think about security in my day-to-day coding. Anyone here enjoys thinking about security at the same time they're trying to implement that feature? I haven't got time for thinking about security. I've got features to implement.
No,
Seems
we love the
familiar. Okay, so let us...
let's try this on a case study then.
Yeah, we'll start with this case study. This is the story about an online bookstore. Okay, it's a real case study, so we have to obfuscate it a little bit. It was not, they were actually not selling books, but they were in some other domain. So this bookstore had a security audit. They pulled on a security team, where we were involved, to audit and test what they had in production. So the team started fiddling around with infrastructure, checking out port scans, checking out the web servers, how cook and state handling, etc. And didn't find anything. After a while, one of the testers got curious about the quantity field where you ordered book. HAMLET, 1 copy. HAMLET, -1 copy.
That's what we all do, right? When we're on a website. Yeah.
So what happened? Actually nothing. The order was accepted.
You mean that the order got, the system didn't even react on it?
No, you checked out using your credit card and registering as a customer, Joe Tester, at the headquarter, and the order just got accepted. And nothing happened.
Except for the next day.
Yeah.
That's when a woman from finance came in, had a credit invoice to Joe Tester. Saying, hey, who's Joe Tester here? Because we need to pay out money.
That's me. Not me, but that's I-ish.
See the problem here? That for some reason, -1, the bug, ended up in paying out money. So that's just a bug, right?
Yeah, that's just a bug. But let's just check. Is it a security concern? If the web shop just starts handing out money to people who are not buying books, is that a security concern? Well, yes.
Sort of.
No?
Yeah, the CEO thinks so. Yeah.
Is it a...
No, they didn't get a book. No.
No, they didn't get the book. They should send out someone to collect that book. Okay, so, but is it a bug?
Yeah.
Of course it's a bug. We can all see it in our head. The code is missing some kind of if quantity less than 0. It should be there. It's just a bug. And that's true, because security weaknesses are just bugs.
But that means that as a developer, I'm used to squashing bugs, you know?
And you're pretty good at it.
Yeah, well.
Actually, he's pretty good at it.
The thing, though, is that I'm afraid of security, right? Because I don't like security. I'm like, no, that's somebody else's business.
It's a little bit scary and hairy.
But if I ask you, like, are you concerned with, response times? I mean, you don't go like, hey, response times. No, that's not my business. All right, slow code. Yeah. No.
When we need fast response times, we'll get the response time team in to do a response time audit and fix the response time configurations. No? Not capacity either. We don't have a capacity team that comes in and makes a capacity. But security.
So that's kind of odd.
It's just a non-functional requirement. And the weaknesses are just misbehaving code. So we fix them.
So that's perfect. That means that we can actually address this the normal way.
And what we also can do is that if we can use our design habits to write nice code, we will avoid a lot of those bugs to start with. So you all here know a lot about software design. And if you just concentrate on using, well, some parts of that, keeping that on top of your mind, and that's easy to do. You'll just spontaneously write more secure code.
Okay, so that's fine. But let's analyze our -1 problem now from a DDD perspective.
Yeah, because we said domain-driven security is using DDD tools to get security benefits.
So one observation is really that the quantity, somehow it was modeled as an integer, right? I guess the developer that was in charge, the domain expert said, you know what, you can order, 5 books.
He said 5 books. Okay, that's an int. I know how to code that.
So that's good.
So no more questions.
The thing is then that quantity becomes an implicit concept.
Implicit in meaning, if you look in the code, it will say int quantity. It will be implicit. It will be in the variable names of parameter, but it will not have a proper home in the code. It will not be explicitly represented.
This is something we see a lot, right? I mean, it says string email or string phone number. Let me know it's a phone number.
Anyone has a system with email addresses in them? Yeah.
Okay.
Anyone who's got a system with email addresses represented as strings or varchars.
But the analysis then is that, from a modeling perspective, we're probably missing a model, or it's incomplete at least, right? Because if you look at this from a contextual perspective, in the input context, in the browser, sort of say when you enter a number.
Over here, we've got a text field, basically. It's an integer. It's an integer. It's a string.
But as soon as it enters our world, our domain,
our view of the world,
it becomes quantity. And that's the semantical, meaning. This the meaning of that -1 suddenly.
So what we think is that we think about this. We think about an order line with an ISBN number and a quantity. It's our perceived model, the model that we've made of how we perceive things. And we need to make that explicit.
And this is something that you can actually do if you compare how you model things. If you use shallow modeling, that's really like, how can I implement this?
Yeah, the kind of, it's an int. Let's go for it. Take the first model you find, code it using primitive types. And when testers have got the same mindset, they will probably just verify, can I order a book? Yes, I can. Job's done. And you end up with risky security.
But if you use a deep modeling concept, then you start asking questions about it. So what is a quantity? What's the upper limit? What's the lower limit?
Can I order 4.5 books?
Probably not, right?
Okay. Can I order -1?
No.
Can I order 200? 2
well,
billions?
you know what? I need to check with shipping, because it depends on how they pack things.
Trick of the trade: ask for upper limits.
Yeah, that's pretty good.
No, but actually, that's one thing we do. As soon as you have a conversation with a domain expert, you start asking, okay, how many things can I put in the basket? And they say, no, a lot. There's no limit. Okay, can I put 1 million different books in the basket? And they go, no, you can't. Okay, why not? What's the upper limit? And if you start that conversation, you will probably learn something about the domain and about the business. Like Daniel said, we can't ship it. Why not? Well, because the online bookstore is using the order through logistic flow. Okay. And if you want to order more, then you have to use the bulk order flow. Okay. What's that? Well, it's about how they do that storehouse. It's about packing and shipping and boxes and stuff like that. Okay. I understand the business on a deeper level.
And this is actually something that's really, really important, because like you said, it's reasonably secure if you use this. And this is what secure by design and domain-driven security is all about. It's not necessarily absolutely secure. It just reduces the attack surface. And sometimes it reduces so much that you can't attack it. Right?
No guarantee. You can't sue us.
Good. Yeah.
But what we are going for is the deep modeling, where you stand the question, do I understand it? You will exploit many different models to feed the conversation. You will do the testing more exploratory style. Oh, does it work? Can I do this? Is it sure that I cannot do this as well? That's why you get it reasonably secure. And what you probably will see in the code are less of primitive types and more domain types.
And that, of course, brings us into the next topic here, is domain primitives. And this is something that you all have encountered, most of you anyway. And it's a value object. It tends to be a value object, but it has some certain properties that we will see. So what kind of primitives do we have normally?
Yeah, if we look at the programming language, we have the basic building blocks that make up our data types. We've got ints, strings, booleans. That's kind of the minimal things we do to build up. And when we talk about computers and computations, these are the natural things to talk about. We add integers together, we append strings. But that's for the scope, the domain of talking about the programming language. If we look at a domain, such as railway system, what are the basic building blocks for talking about a railway system? It's not numbers.
Well, of course, it's train numbers, station code, and arrival time, right? And you know arrival time, 5 minutes late is on time. Right. So that's the thing.
So if we look at train number and station code, if we have train number 47 and station code 200, can we add them to 247?
That doesn't make sense.
Doesn't make sense. But if they're both integers, it makes sense to add them. So station codes and train numbers are different kind of creatures. They are different types. And if we look at the conference schedule, we are in room 352.
53.
53, sorry. It doesn't make sense to double it.
Okay, Dan, I see that. But this is kind of, abstract, vague. I really want to see the code now.
Yeah, but obviously. Nothing strange. A plain old Java object, a value object which is preferably immutable. We really love our finals. In the inside, it's a wrapper around a string, in this case an email address. But it can't be any email address. Would it be possible to have an email address? Script, install keylogger, blah, 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 slash script.
No, obviously not. I mean, that's not email. To be honest, this is not every email out there, because this is what we are trying to do. If you look at the cloud here, you see that that's the representation of all strings. This is the reason why you shouldn't represent an email address by a string. Because
the script install would get caught in the validation in the constructor. If you just briefly leave back, there's a constructor, and here's a regexp. We all love regexp.
Yeah, let's not dive into that one. No. So the thing is then, what we could, fall back to is that let's use RFC 5322. That's the email address specification.
We love our specifications, don't we?
We all read it. The only problem with that is that you can get some really funky addresses out of it.
This is actually a proper address according to specification. And this is a proper address. Do we want root at 127.001 as the customer contact address?
That's perfect, though.
I just love it. It's a wonderful way to start launching an attack.
So the thing is that what we have there in green is really the addresses that we wanted, that we saw in code just recently. And that's the precise definition of an email address in a particular context.
So in this case, it would be, if we look at the regexp, it would be email addresses that fulfill some length and structure criteria and all reside in hospital.com.
But then if you have that limitation, doesn't that really mean that I can't use your email address in my part of the system? Doesn't that become bulky?
That's true. Probably this email address definition is crafted for this hospital. It's for internal communication to ensure that patient journals are not sent outside. But if I carry that away and go walk around within my department, say, do you agree that this is a good definition of email address? They say yes. And then I walk a little bit further, and they say yes. And then I walk across the aisle over to finance department.
And they might say no, right? Say like, no, that's not an email.
So this is my definition of email, our definition of email that's valid for our system. And we have the liberty to actually define your domain.
Interesting, because this actually brings us to the next part. But what we have covered so far, which is important to note, is that we have added security properties to the small scope. Your tiny value objects, your, small helper. It could be a functional language, it could be a function that behaves a certain way and such. And that sort of solves the problem of the negative quantity, right?
So now let's zoom out a little bit and look at what's happening in this context when the email address, we're probing how far away we can take it.
And of course
And how... Oh, sorry.
Sorry about that.
And how far, what happens when we reach the border of the definition and what happens beyond that.
Yes.
So,
And this naturally brings us to the domain-driven design concept of bounded contexts. And you all know that that's a really important thing in DDD, right? Because each bounded context has its own language, semantics, and has a corresponding domain model that adheres to this, right? But as soon as something inside of this context goes outside of the context, that meaning might change.
And it might change subtly. You might not notice it. You carry it across the border over to the next department, and they suddenly interpret it slightly different. And that might cause really nasty bugs. So that's the warning. Be aware when things move out of its boundary.
So let's bring an example of that, and that's what we have here.
Yeah. So if we have, for example, online sales of books, we have the concept of order. And it might be easy to be lured into thinking that concept of order is something that the entire business agree on, and thus the entire code agree on. But we probably have different places where order is used. For example, order in sales, they are concerned about what's in the box, what should we put in what books and what quantities. If we move over to shipping, they're pretty uninterested in what's in the box. They're concerned about moving it from one place to another. So for them, the destination it's going to is the important part. And in finance, they care about nothing about this. They just care about what's the value of it, setting up debts and payments.
So this really means that if you have a common order class, if it's Java, with, I guess, a bunch of optionals, there are fields, right?
Because you need a lot of optionals to serve all three purposes.
Yes, and in one context, those will be, empty, or if you don't use optionals, could be null, right? That could induce a lot of strange behavior, and you have some defensive coding in there, and you can blow up. That's a huge problem.
So instead, you should be aware that if there's actually three different meanings of order, the word order, then let so be. You might have one class order in the shipping domain, which is crafted to its purposes. One class order in the sales, and one class order in finance. And now, and this is the important part, you need to be aware what happens when you move data from shipping to sales. How do these data map onto the other order? Order in shipping maps to order in sales or to order in finance. So instead of trying to make one big domain to rule them all, the grand unified domain, which you all have dreamt of, acknowledge that, well, this is not a huge island, it's an archipelago, and set up which mappings are the important.
Okay, Dan. But still, this is context mapping. I'm going to try an example here. I'm going to try to correlate that to SQL injection that we saw in the beginning, and another famous one, cross-site scripting.
Okay, so that would be applying it to a technical domain.
Yes.
Yep,
here on the left, of course, we have a classical SQL injection.
From the GUI through the application down in the database doing something nasty.
And on the right, we have the cross-site scripting. That's if it's reflective or if it's a stored one, it goes from the inside to the outside and executes that code.
And do something nasty when it leaves.
Yeah, but the problem here is that in this kind of picture, it's hard to understand where the bounded contexts are.
Can you draw them in a different way?
Yes, we could draw them as hexagons, and that's usually what you do when you have, microservices, right?
Hexagonal architecture, it's a very nice style of visualizing architecture. Do not focus on stacks, but focus on inside and outsides rather, adapters and connectors.
So here you can actually see that on the left was the SQL injection. It's actually the same thing, and you see that you're crossing that semantic boundary there, and that's why you have prepared statements.
So this leads us to understand that we all know that SQL injection, the prepared statements are the way to stop SQL injection. This is why. prepared statements ensure that the shift from the application down to the database is making a sound mapping instead of misrepresenting it as SQL command.
And the same thing goes, with cross-site scripting. That's why you have the escaping part.
So we actually see that SQL injection and cross-site scripting are actually the same thing. They are examples of broken context mapping when we move from one subsystem to another. In this case, browser, application, database, etc.
But to be honest, this is really simple to understand. Everyone nowadays understands SQL injection. They understand, cross-site scripting. But what's important by having this understanding of context mapping, we could actually start to understand more complex attacks, such as second-order injection.
Okay, so what's a second-order injection?
Well, a second-order injection is when you actually don't target the primary system, but rather a secondary one.
Okay, so you send some bad, maliciously crafted data to me.
Yes.
But it's not me that you're after.
Exactly.
You know that I'm going to hand this data to someone else behind me.
Yes. So for instance, we could shoot it in, you would log my request.
Yeah, I get that strange username. And goes, this doesn't make sense. I put it on the log.
And then you have the log admin tool that's inside of the firewalls with, admin privileges, reading that log, and all of a sudden we execute that code because it's a web-based one.
And trying to understand this by drawing stacks, I've tried it. I never got through it. But we're viewing it as a hexagonal architecture. It becomes much more obvious where the problem is. The problem is not when we log it, it's when we view the log. So we know how to shift blame appropriately.
Okay, so if you turn back to the different contexts again, and we have microservices.
Okay, so let's back out from the technical domain.
Yeah.
Now we have microservices that do some business service.
Uh-huh.
Oh yeah, we had three.
Yeah.
Sales,
shipping
and finance. Yeah. Daniel, it's not obvious that we need to make an elaborate context mapping for this.
Oh, you mean, okay, I see what you're saying. These are three services.
We can keep that in our head.
Yeah, this is a microservice architecture, right? But this is not the way it looks like. It looks like this, right? You have, 300 plus services.
Yeah. So Netflix talk about that 300. The Avanza Bank of Sweden got
400 or 500. I'm not sure.
500, etc. So this is when context mapping is crucial. Or imagine that you would unify all these to grand unified domain, to have one definition of a customer that will serve all 300 different views of it. That will be a large object with a lot of setters and getters, with a lot of optionals, and it will probably be able to be configured totally any way it can be.
So, but then this is really, green field, right? We tend to be in old monolithic systems. Yes. So, of course, we need to understand how to do all this in legacy code, right?
So, we have kind of like scraped our experience, and we got a 3-step procedure that we usually do to get this started in a legacy code base. We find somewhere to draw a line, identifying where we should do the job. We harden that API, and we then proceed on the inside to declutter things, especially entities. So let's take a close look at these steps.
So let's start with the first one, draw the line.
Yeah, how do we find where to draw the line?
And this is really about finding that semantic boundary. When your data implicitly changes meaning, just by, passing it, if it's a monolithic system, by doing, a method call to some other, class or whatever. Or if it's a service-oriented, when you pass data through between them somehow. And what you can do at this point, where you find that, particular place when this changes.
Okay, so you find a subsystem or a module where you think this is a nice part.
Exactly.
Okay, so what do you do then?
At that particular point, you add a internal translation layer. And what you're really after right now is to understand how bad your data is. Because you get them as strings, objects, generic types, XML, whatever it is. And you translate those to those domain primitives that you wished you had.
Okay, so let's be clear. When you draw the line, you do not touch the methods, the outside use. You do not touch the signature.
Exactly, it's
They
a
are
hidden
still
thing.
int strings on the outside.
Yes.
Okay, but on the inside,
And
just inside the border.
yes, and then now internally we can be strict. We could either say, hey, we're going to reject your data. But usually when you do that, people start complaining because they're not used to having this strictness in place. So if that's the case, you can't do that. You need to start, logging it, saying, hey, this data fails because of our new rules or our strictness. And then you can start analyzing that and say, you know what, we need to shape up. And by doing that, you can, take it step by step to enforce this strictness.
So this does not only apply when you pull things from the outside. If you read stuff from the database.
Oh, that's the same thing.
That's the same thing.
Yes.
We lift it into a domain. Mm-hmm. Anyone here has got a database where some of the rows are not perfectly adhering to the rules?
I don't know. Oh,
okay,
wait.
so if
you are so lucky. Yeah.
If we enforce this at the database, it will just say, bang, no, you can't work with this customer. That might not be feasible. And that's when we use the other strategy to, okay, we note it, we log it for some administration, customer service, but we continue working with it.
So, but when you have done that, you can actually start, enforcing your consumers to understand what kind of quality of your data that it needs to be, right? So then that's when you can start hardening your APIs.
So hardening your APIs is that when you aggressively start changing your API from just saying by book, string, which is an ISBN, int, which is a quantity, and changing the signature of your outwards facing API to actually ask for an ISBN and a quantity.
And of course, if that's, if it's a REST API, you pass JSON or whatever you do, of course, those requirements would be stated in your, Swagger files or whatever you have, and then you would convert into those types. And if it doesn't match anymore, you would reject it. So this actually makes you create a library of your domain primitives, and you can start focusing on the inside of your,
What happens that what we're looking for, another rule of thumb, if you look at all the arguments, parameters, and all the return types of your outward-facing methods, those should be domain primitives or other domain types. Domain primitives, the small stuff, or richer domain types, that's fine. But it should not be language primitives.
So if you look at the third pattern, it would be the cluttered entity problem.
So if we look at what, for example, the inside of an entity probably looked like. Order here has got an add item that takes an ISBN quantity and has a lot of stuff in it, validates a lot of things, checks the inventory, and then add. It's actually cluttered with a lot of things that are not really entity-ish to do. Checking the availability and adding to the cart. Well, that's entity-ish, but all this validation stuff. And you all notice that's actually missing one of validation.
The -1. Yeah.
Oh, crap. Wasn't it obvious that this might cause like a severe loss of money? And to be really honest, how many of you have seen entity methods that are longer than 12 lines? Anyone seen longer than 100? Keep your hands up. And it's seen longer than 200, 400, 600, 1,000 lines.
You can go further.
2,000 lines.
Yeah.
Oh, no, I'm
Okay,
sorry, I'm
good.
stopping. Oh, I'm sorry. I've not seen an entity method of 2,000 lines yet. I'm so happy that I'm not in your seat.
So,
But 600 lines,
I mean, that
often
happens.
cluttered with a lot of details. So if we do start using the domain primitives on the inside and make the entities like stand on the shoulders of domain primitives, we'll end up somewhere like
Not there. There we
there.
go.
So the entity is now much more entity-ish. It's only doing entity stuff. It's finding the book in question, checking for availability, and adding to it. All the validation is now inside the ISBN quantity domain primitives.
And there's actually another nice positive side effect from this is that you can, by looking at this, you could almost bring in the domain expert now and say, this is how we reason about this. And they can read this and go like, yeah, it sort of makes sense except for all the parentheses, but yeah.
Yeah, you can inventory available books of a specific ISBN should be greater or equal to the quantity that we requested. It's a little bit like Sudoku. It's really hard to solve a Sudoku, but it's really easy to verify that it's been solved. The domain expert would never be able to write this code. No, that's not going to happen. That's going to be a programming job. Writing this code is a programming job, but they can look at it and verify that it looks right.
Okay.
And that's a sweet spot.
So.
That's the
yeah.
3 with context mapping and the 3 patterns for legacy code. So we've covered where we think we have some substantial experience and patterns we want to share with you. And as a final part, we'd like to share something that's still an open area.
And that's the domain DOS attack, and this is the juicy part now. Okay.
Okay.
Yeah.
Denial of service. Familiar?
Yeah.
Yeah. Sure. Domain DOS is using the same thing, using domain attacks, domain-based attack to provoke a denial of service, not availability. So it's availability breach of security.
Okay, that sort of makes sense, but it's kind of confusing.
Yeah.
I think we're going to bring up an example. I think that's better.
Fair enough.
So here we actually have a hotel manager that wished to, make it better for all its customers, make it more flexible.
I'm the hotel manager.
Huh? And
I think it's a great idea. People can have their reservations open until 4 p.m.
And then it can cancel without charge.
Because life happens, and we want to be nice to our customers.
The only problem is that by having that service in place, someone could,
Someone. I'm not pointing fingers.
No.
But someone.
I guess we could, reserve all rooms.
No, you couldn't.
And then we could cancel without charge at the latest point in time.
Why would you do that?
Because then traffic would go to my hotel, right? Maybe it's a conference called DevOps in town, and people would book a certain hotel instead of the other one. Yeah, could be done.
Okay.
Oh, but this is just an example, right? This doesn't happen.
This doesn't happen in reality.
Right. Okay. Everyone knows Uber, right? Well, we have different ideas about that company. The thing is that in India, Uber has a competitor called Ola that does the same thing. The thing is that Ola they actually created like 70,000 accounts, and they booked over 400,000 rides.
No, they booked rides.
Yeah, they booked them. They're right.
They booked rides. They were not rides. They booked rides. They were following the domain rules.
And they canceled them.
And you're allowed to do that.
What happened to the Uber drivers? They didn't get any drives, so they quit. And well, Uber got in trouble. So Uber is really the poor little Uber.
Yeah, Ola are the bad boys, aren't they?
Yeah.
And Uber are the poor victims.
Yes, the victims.
Yes.
Well, if you look in San Francisco, we have Lyft. and Lyft is a competitor to Uber. And obviously, Uber canceled more than 5,000 rides. Yeah. So I guess the biggest problem with all of this is that what we are doing is that we're using valid domain rules that normal usage uses, but we're using it with a malicious intent.
Yeah. So, this is still an open question. We are doing some industry work. We are collaborating with universities. We think there are ideas from fraud detection that could be valuable, and it's still an unresolved question. Which brings us to a wrap-up.
Yeah. So now we've actually learned how to place, security on the little scope, the domain primitives, and also the larger scope, context mappings, and how to use different patterns in legacy code. And of course, you start to think about those, evil domain DOS attacks, and don't use them. No.
So, hope you've been enjoying this session. Thanks for your attention. And we will hang around here to take questions. Just afterwards here. So, thanks a lot.
Thank you so much.